Hello again, Mr. Ruthman back, and we are talking about section 4.2, which is arithmetic sequences. So our first section was all about defining a sequence and looking at partial sums and our special notation for those sums. But this section and the next section are talking about special kinds of sequences. So we'll start with arithmetic sequences. These are sequences of this form. What does that form mean? I know most of us are looking at that, asking this question. Well, we have a first term. Then our second term is that first term plus some number, d. Our third term is the first term plus 2 times that whatever d is. So in general, an arithmetic sequence is one where the difference between each term and the one before it is constant. So if I look at this sequence, and here I'll erase this so we can see more clearly, the difference between the first and second terms is d. The difference between the second and third terms is also d. We have plus d and plus 2d. Then the difference between the third and fourth terms is d, and so on. So each term is, the common difference is d. So d is what we call the common difference. And this will make more sense once we see some examples. And then a sub 1 is just the first term of the sequence. And then we have a formula for the nth term of any arithmetic sequence, and this is given by a sub n equals a1 plus n minus 1 times d. And that should make sense to us. If there's d is the difference between any term and the term before it, then that's where we're getting n minus 1 times d, and then we're always starting with the first term. So how do we use this information? Let's look at example 1, letter A. If a sub 1 equals 2 and d equals 3, then find the nth term of the arithmetic sequence. The nth term is just this formula. And they gave me a1 and d, so I can just plug into my formula. 2 plus n minus 1 times d is 3. And if I simplify this, that's 2 plus 3n minus 3, which is 3n minus 1. And that's it. Let's look at an actual sequence, though, one where we can see that common difference. So given the sequence 9, 4, -1, -6, -11, and so on, the 3 dots, find the nth term of the arithmetic sequence. So they didn't just tell us what a sub 1 is, they didn't just tell us what d is, but they gave us more than enough information to figure that out. So my first term is 9, so that's going to be a sub 1. And then what am I adding or subtracting to each term to get the next term? I'm subtracting 5, so d equals -5. That means a sub n is 9 plus n minus 1 times -5. And again, I can simplify this. 9 minus 5n plus 5, or 14 minus 5n. All right, now letter C. We don't actually graph these very often, but I want us to understand what an arithmetic sequence is actually doing. So if I graph this, just take this simple example. Let's think if n equals 0, think of this as y equals 1 plus 2 times x minus 1. So if x equals 0, then y is going to be -1. If x equals 1, then I'll have 1. If x equals 2, then I will have 3, and so on. What kind of a graph is this? This is linear. I have a constant rate of change. And what is my slope? My slope is up 2 over 1. So my slope is 2. What was d in this nth term formula? D was also 2. So in general, an arithmetic sequence is representing a linear function, and the slope of that linear function is the common difference. It's d. So I just think that's interesting, and it helps us keep track of what an arithmetic sequence is, because next section we'll start talking about a different kind of sequence, and we want to be able to differentiate, to distinguish between the two of them easily. Let's take a look at some more examples, though. So find the first 5 terms and the 300th term of the following sequence. So here they only gave us 2 numbers in the sequence, but that's still enough information to figure out what the nth term is. My first term is 13, and then d is -6. I'm subtracting 6 to get to 7. Let's see. So n is 13 plus n minus 1 times -6. And if I distribute the -6 and simplify this, this is 19 minus 6n. So I'm going to let you use this formula to find the first 5 terms. You're just plugging in a1, so plug in 1 for n, a2, a3, a4, a5, and then the 300th term, you're still just plugging in 300 for n. All right, so go ahead and do these problems on your own. We can talk about those answers if you're confused. But I'm going to move on to example 3, because example 3 is a little different. It's a really interesting example, and it's one that you will see on tests and quizzes and exit tickets, perhaps. So it's one that I want us to be able to understand. Find the nth term of the arithmetic sequence and the 1000th term, given that the 11th term is 52 and the 19th term is 92. Where do we start? Well, what do we need? We need the nth term formula. And they told us that A11, the 11th term, is 52, and the 19th term is 92. Well, the 11th term is the first term plus n is 11, so 11 minus 1 times d. The 19th term is the first term plus 19 minus 1 times d. So if I simplify these, so I have two equations and two unknowns, two variables. What can I do? How can I solve this? Let's think all the way back to Algebra 1. I have a system of two equations with two variables, with two unknowns, so I can use substitution or elimination. I'm going to use elimination, subtract the second equation from the first. My a sub 1's go away. 52 minus 92 is -40. 10d minus 18d is -8d, so d equals 5. If d equals 5, then 52 equals a sub 1 plus 10 times 5. Subtract 50 from both sides, so a sub 1 equals 2. So that means my nth term formula is 2 plus n minus 1 times 5. And then, now I can actually answer the question that they wanted. The 1000th term is a 1000 equals 2 plus 1000 minus 1 times 5. Plug all that into a calculator and you get 4,997. So again, you will see questions like this throughout the unit. It just make sure you're setting up your system correctly and that you're not making any algebraic errors when you're solving that system of equations. You should be good to go. Now, of course, we wouldn't have spent all that time in the first section talking about partial sums if that was the end of it. So even for arithmetic sequences, especially for arithmetic sequences, we can look at partial sums of these. So this is what that S sub n notation would look like. But there is an easier way to go about solving this. There's actually a formula. The nth partial sum equals n times the first term in that partial sum plus the last term in that partial sum all over 2. Now, this may be asking a lot from us, but let's think all the way back to our first week of school. We did a bunch of interesting math puzzles and answered some math questions. We actually derived this formula ourselves. I believe it was Friday of the first week of school. We talked about Gauss, and when he was in school, he was presented with adding all the numbers from 1 to 100 together, and he was able to do this incredibly quickly, and that's because he derived this formula himself. It turns out this formula works for partial sums of any sequence. So if you want to talk about where we get this formula, look back at your notes or come ask me, or look up Carl Friedrich Gauss online. It's an interesting story. So now we just use this formula. We don't have to worry about much else. Find the sum of the first 40 terms of this arithmetic sequence. First 40 terms, that means I'll need, from my formula, a1, which is 3, but I also need a40. I need the last term in that partial sum of the sequence. So how do I find a sub 40? Well, I'll use my nth term formula. So an is 3 plus n minus 1. What is my common difference here? I'm adding 4 each time, so times 4. So a40 is 3 plus 40 minus 1 times 4. 3 plus 39 times 4, I plug all of that into a calculator, and I get 159. So a40 is 159. And now I can just plug into my formula. The 40th partial sum of this sequence is n, which is 40, times a sub 1 plus a sub 40 all over 2. And I plug this into a calculator. 40 times 162 all over 2, that is 3,240. Now, just stop for a second. Maybe it's just the math major, the math nerd in me. But the fact that we can use such a simple formula, such a simple process, and add up 40 different numbers is insane to me. It's so interesting. It's so fascinating that we are able to do this so easily, with or without a calculator. So sometimes you just need to stop, take a look, and see the beauty in mathematics. Go ahead and make fun of me, but I love it. So, moving on. Example 5. Find the sum of the first 50 odd numbers. The first 50 odd numbers. Well, let's start by writing out part of that sequence. 1, 3, 5, 7, 9. My first term is 1. My common difference is I'm adding 2 each time. So my nth term is 1 plus n minus 1 times d. And if I simplify this, 1 plus 2n minus 2, this is 2n minus 1. How interesting, but not entirely coincidental, that this matches that formula for the odd numbers that we came up with in the first section. The sequence of odd numbers is a sub n equals 2n minus 1. So if we want the sum of the first 50 odd numbers, I need a1, which is 1, and I need a sub 50. A sub 50 is 2 times 50 minus 1, or 99. So now I can plug this into my formula. The 50th partial sum is 50 times 1 plus 99 all over 2. 50 times 100 divided by 2 is 2,500. All right, 2 more examples. This section isn't quite as long as the first. Example 6 is an interesting word problem and also one that I recommend you know how to solve. Hint, hint. An amphitheater has 50 rows of seats with 30 seats in the first row, 32 in the second, 34 in the third, and so on. So each row is adding 2 seats compared to the row before. Find the total number of seats. Well, we might be stuck, but just take a step back and look. This is an arithmetic sequence. I have a common difference between each row, between each term number. And that's 2 seats. I'm adding 2 seats each time. So that common difference is 2. And I'm starting with 30 seats. So a sub 1 is 30. Find the total number of seats. That's going to be, well, for 50 rows of seats, the 50th partial sum. So that means I need the first term number, which is 30, but I also need a sub 50, which means I need a sub n, which shouldn't be too difficult. A sub n is 30 plus n minus 1 times 2. So a sub 50 is 30 plus 50 minus 1 times 2. So plug that into a calculator. 30 plus 49 times 2, 30 plus 98, that's 128. So that means the 50th partial sum is 50 times 30 plus 128 all over 2. So there are a total of 3,950 seats in this amphitheater. Seats, I guess. Should make sure to write the units. So the word problem looks complicated. Looked like it might take us a while, but with arithmetic sequences with our partial sum formula up here, it's actually not too bad at all. Let's answer one last question. This is a fun one because it requires us to actually think. I love it. Our total is 572. Total means that's our sum, that's our partial sum. So 572 equals some partial sum. I want to know how many terms. So I don't know what n is. I just know it's the nth partial sum. And that's going to be n times a1 plus an all over 2. Well, they gave me the beginning of the sequence. So a1 is 5, and my common difference is 2. I'm adding 2 each time. So that means an equals 5 plus n minus 1 times 2. If I simplify that, that's 2n plus 3. So my an is 2n plus 3, so 572 equals n times a1 we just said was 5, plus 2n plus 3 all over 2, which is 5n plus 2n squared plus 3n over 2. 572 equals 2n squared plus 8n over 2. Divide out the 2. I have something squared plus something to the first power. This is a quadratic, so subtract 572 from both sides. And now I need to factor. Either use your x, use the quadratic formula, I think would probably be easier in this situation. And whichever method you use, you can also complete the square, though I'm not sure why you would put yourself through that. You get 0 equals n minus 22 times n plus 26. So n equals 22 or negative 26. Can I have a negative term number, though? That doesn't make any sense. So throw that out. N equals 22. So I need to add 22 terms of this particular sequence to get a total of 572. So there are a lot of fun, interesting questions we could ask about these kinds of sequences like we just saw. Overall, though, This is about all that you will see, all that you'll need to know how to do. So rewatch parts of this that confused you. Go ahead and write down your questions, work through some examples of your own. Make sure you're answering questions I asked you to on here. And I will see you in class. Thank you so much.